Hello ladies and gentlemen, welcome back to A Mission a Day, episode number 9. And as you might recall, we are in a bit of trouble. We have about 101,000 crowns and we can do no missions currently. The only mission available to us, the Sputnik number 4, requires the 4 sensors, which we do not have at the moment. Fortunately, we have 3 out of the 4 unlocked in the science tree here. And the last mission gave us just about enough science to unlock the last one, the negative gravioli detector. We need 505 science for it and we have currently 267 points. This means we need roughly 300 points, 283 points. That would be enough to get it. Quite a hefty amount of science, and we have 100,000 crowns to do it. Now keep in mind, for the mission we are about to do, we will not get any money because there is no mission, it is just for the science. So this 100,000 has to effectively cover 2 missions. The mission today to get the science, and the next mission that will fulfill the requirements and get us some money again. What I'm thinking, because our destination in the series has become Val, one of Jules' moons, is to jump the gun a bit and send a probe there. Now, it's quite a far destination. This might not necessarily jive with your idea of a cheap mission, but it can be done cheap, I think, and therefore the only trade-off then becomes that it has to be a very small probe. So we have a core, 1 goo canister for the science, some solar panels, a battery, some very small fuel tanks and a tiny engine. We unlock this in the science tree, the miniature space parts, and hopefully this is light enough to pack enough Delta V to get to Joule. Here is a second stage. This is 1 tank and the small engine, and the fairly basic lifter stage of some fuel, a liquid engine and 2 solid boosters. I'm not using the launch clamps because they cost money and I don't have any, and this is a fairly simple rocket that should be able to stand on the booster. So I hope this will be able to, I hope this has enough Delta V to get to Joule. I installed the plugin, the Kerbal engineering redux system. This will tell you how much Delta V your rocket has. It's quite handy in engineering the rocket, but lo and behold, this needs research from the tree as well. I have not found it in any of the nodes, so we might encounter it later. So I downloaded the plugin but could not use it. So here we go to the launch pad and see if we can get to Joule. As before, the launching into orbit will be fast forwarded. I will be talking through setting up the interplanetary node. This is something we haven't done before on this series, so I'll give you some pointers on that. But first, the launch. So here we are in orbit, and I just did all the science experiments we brought along, the 3 sensors and the goo. I'm not sure if you saw, but they all had very low amounts of points, like less than 1 science point. So I think it's fair to say that the near Kerbin space environment has been all scienced out. Now here we are in the map view and we want to go to Joule here. So first step in doing that is to setting it as a target, and then we want to make our orbit match it. Now what I did do before recording the video is time warp to such a point that the constellations are in such a way that a transfer is possible. So if we transfer here, we'll meet Joule in its orbit when the planet is there as well. So that's the first step you have to do. You have to wait for your launch window, and I did do that. And then the second question is how to actually do it, because here we're in orbit around Kerbin, but we want to get in orbit around Joule. Now for all intents and purposes, us orbiting Kerbin on solar system scale, we are in the same orbit as Kerbin. If we do nothing, we will follow this trajectory around the sun. So we can use this as a guideline in meeting up with Joule. This works just as any other orbit. We want to increase our speed here, so the apoapsis rises on the other side, on this point, where we can then meet Joule. Now, this is not as straightforward as just simply burning, because we have to make sure that when we leave Kerbin, when our speed reaches escape velocity, it is going in the prograde direction of Kerbin around the sun. This is called the ejection angle. So we want to make sure that when we leave Kerbin, we are doing so in this direction. So if I plot a maneuver node here and add a bunch of speed, we will see that pretty much goes off in a bit of a slanted direction. So we can drag the maneuver node around a bit, and here we are getting a little bit of a gravity assist from the moon. Why not use that? And if we zoom out here, we can see that no, we're not going to get our orbit because we don't have enough conic patches, as it's called. The game standardly draws 3 spheres of influence ahead. So here we have the first one, Kerbin, then the moon, and then the solar orbit. But it doesn't then give us oh no, that's Kerbin again. It then doesn't give us the solar orbit. So we should have changed that beforehand, but we didn't. So now we're just going to increase the speed. I'm not quite sure how to solve this now. We're just going to have to eyeball it, and then first leave Kerbin and then do another burn for fine-tuning, or we make it in such a way where we don't encounter the moon at all. So if we increase our speed like so, we're not encountering the moon. Oh, we are still encountering the moon, except we're now getting a braking maneuver from it. So this is not doing my example any good. We are going to fast forward a day, so we will not encounter the moon. Actually, it is almost always beneficial to encounter the moon, get a little bit of a gravitational slingshot from it, get some free delta V. But for my example of how to set up an interplanetary node, this is more of a hindering effect than a helping effect. Now we need to do some time warping because the moon is not moving anytime soon. What we are going to do for this is unprecedented. We're going to leave this mission behind. We're going to go to the Space Center, in fact, and we will phone up Jeb with the question, can you send us some science? As you might recall, this is the R&D center. As you might recall, Jebediah is trapped in solar orbit. The chances of him ever getting out there are very, very low. But he is still alive, and he might be able to send us a little bit of science. Here's mission number 7, orbiting the sun. He might be able to send us a smidgen of science, and that will of course also help us in our quest. We are currently in a solar orbit, and high in space over the sun is 200 science points. We will gladly hear of those reports back at home. Now I think if we spam this science, we will even get enough to get the sensor that we want, but we're not going to spam it because that feels a little bit cheaty. And I've read on the forums also that in the future iterations of the game, transmission spamming will in fact not be possible. There will be actual tangible benefits to bringing your science back home. At any rate, Jebediah has given us a little bit of help, and now we have no choice but to leave him behind again, sadly. What I did forget to do there was the time warping, which is what we came to him for in the first place. Oh well, I guess we're going to take advantage of the Munar slingshot anyway. If you don't understand how a gravitational slingshot works, feel free to leave a comment and I will gladly make a video explaining that. If I go into that in this video, it will become a little bit off topic and distracting for everyone, I think. So I'm going to try and set up the interplanetary maneuver node again. Have I put Joule as a target this time? No, I have not yet. So I'm going to go for a ejection angle that will take me past the moon. No, yes, like so. And we can see that this, well, it's not quite. We want to have this green ejection trajectory to be almost the same as the Kerbin trajectory around the sun, so that way our orbit becomes nice and tidy. So here we get the moon encounter, and it will drag us along a little bit, give us a little bit of a kick. and then we will find ourselves in solar orbit. Now this is a 1000 meters per second delta V burn, quite a large one. I'm going to do it and then go past the moon, do some science, and I will speak to you when we are in solar orbit. Until then, enjoy the fast forward. So here we are, leaving the moon and Kerbin behind. We are now in solar orbit. Here in the distance we can see them still. So we're going to do a quick round of science experiments and then set up our trajectory to Joule. So transmitting that goop data back, that gives us some nice science points. Pressure data doesn't work here. Seismic data doesn't work here. I think these are reasonable restrictions. And the temperature scan, that's a bit strange. Why wouldn't it work here? You can get the temperature, surely. Right, so setting up our trajectory to Joule, you can see our orbit pretty much matches that of Kerbin, except it's a little bit larger, which is reasonable as we've been adding energy all the time. So now we are going to raise it all the way up to Joule and see if we can't get an encounter. So making a big burn, increasing the apoapsis until Joule's altitude. And you can see here we get a nice, neat Joule encounter with a periapsis of 700,000 kilometers. We see if we can't get that a little bit lower, 600,000. And like this, it's even more. So we are going to settle for the 600,000 and see if we can correct that mid-burn. Now this is the largest burn so far with 1600 meters per second required. I'm going to do that. Excuse me. I'm going to do that, fast forward it for you, and then see you at the mid-course correction. So the encounter with Joule has been set up. What we want to do now is match our planes of orbit. See, Joule is a little bit inclined relative to Kerbin, so as I set the target here, set the target as Joule, here, lose it and now we set it, we get a descending node marker. Going to put a maneuver on that and then adjust our orbit's plane to see if we cannot fine-tune our encounter so that the periapsis becomes a little bit lower. Get a little bit closer to Joule. No, I have no idea what that's doing, so I'm just not going to fiddle too much with it. Instead, I'm going to increase the time warp to a ridiculous 100,000 times and gently float over to Joule. See if we can't plot an intercept if we are a little bit closer to it. Now, while we're in transit here, allow me to draw your attention to another YouTube channel. This is Jay Cheetah's channel. He's a guy I met on the forums of Kerbal Space Program, and he makes some quite nice videos. They're called the Kerbal Exploration Society, where he makes crazy rockets and goes to weird places. Have a look there, it's in my featured channels list, right next to those subscribe, like buttons and all those, so click all of them and then check out his channel. Additionally, there is a forum topic on the forums where a lot of YouTubers post their channels and their videos, so if you want to look for more videos, check it out. I'll put the link in the description. If you aren't a member of the forums yet, register by all means. It's a nice community, they know a lot of things, and they have videos, pictures, challenges, discussions. It's a great place. Well, in the meanwhile, we're halfway there to Joule, so I'm going to reduce the time acceleration and see if we can't improve this encounter. This probe, it has a little bit of fuel, it can do some course changes, but nothing too drastic. So we have a periapsis here of 2 million kilometers. I want to reduce that so we can get an encounter with Joule to either probe its atmosphere or use it for aero braking. So if we just reduce our speed. Alright, here we are. This is what the mission was all for. We're very far out on the edge of the solar system. Look, the sun is very, very small indeed. And we are now officially in Joule's sphere of influence. Now let's have a look pointed straight at the ground. And this is pretty much our heading as well. There in the distance, a green ball, that is Joule. So first we're going to do some science here, now that we're under the influence of Joule's gravity. High in space over Joule, so transmit that home. And so far the science points aren't massive. I'm hoping I can get some science from these guys. The pressure scan, no, that doesn't work. The seismic data, that doesn't work. So I'm going to do the goo again. So far I'm being underwhelmed by the amount of science we can get from everything here at the Julian system. And what I think I saw, yes, we're going to get an encounter with one of the moons as well, and then we're going to go low over Joule. So our plan now is to do a flyby of Tylo, the moon here, get some science from that, and then hit Joule's atmosphere, graze that, use it for braking, get science from that, and then see if we can get an encounter with Vol or something else, but could very well end up crashing either into the Julian atmosphere or not braking enough and still going in an errant solar orbit. These are both things that are quite likely to happen. First, here we are getting close to Tylo, and then after that Joule. We are first going to do more science and then see if we can't fine-tune our trajectory a little bit. So here in the flight scene not a lot has changed. Joule is quite large. We're still traveling at 1.8 kilometers per second relative to that, but even in our few days of time warp it hasn't grown appreciably larger. So going to see if we can't tweak this. If we slow down a little bit, we are ooh, this is a large maneuver. We cannot do a maneuver that large on our little tank, I don't think. So yeah, any significant braking maneuver is going to be too expensive in the Delta V, but maybe we can steer in such a way that we will in fact hit Joule. That would be nice. If we move it up a little bit closer. Yes. Here we go. We're gonna get it. We're gonna get it. If we go towards it, we will miss our encounter with Tylo. That is a bit of a pity. And here we'll get a lathe encounter. This is 180 meters per second of Delta V. And then with this maneuver we will end up in the Julian atmosphere. We will try and aim for an periapsis of about 90 kilometers. That feels just about right. I don't know why. We're gonna see what happens. 200 meters per second Delta V. I think we have that in the tiny probe tank, and if all goes well, get science from Joule's atmosphere, science from Joule's space, and then have slowed down enough to possibly get intercepts with the moons. Because we're somewhat in the right plane for that. Great. So sit tight as I fast forward through these maneuvers. Here we go, 86 kilometers. That sounds like a good altitude, and if it's not, we'll shoot out of the system, and if it is, we will get a nice Julian orbit, and if it is too shallow, which is a distinct possibility, we will get one go at sampling Joule, and then the probe will be destroyed. So, quite exciting what is going to happen. This is our first stage. Here, let's see, where is Vol? Which one is Vol? Is Vol even a Julian moon? Lathe. Oh yeah, and there it is. One of the inner moons, Vol. This is going to be our target for many a mission to come. This one today, if we're lucky, we will be able to go past it. But first we're going to approach Joule a little bit more carefully than we did the moon in the mission where Jeb got stranded in solar orbit. We don't want a repeat of that. And look, there you can see the moons go around quite pretty. And here we are getting closer to Joule, still at 55,000 kilometers. Going to do some science, if we can. It's still high over joules, still we're going to transmit it home, because why not? We can. We have the power, even though the solar cells really don't charge fast this far from the sun. That's a bit of realism that KSP has added. Okay, so here we're coming in. Joule is incidentally about the size of Earth in the real world. So, just a little tidbit for that. In the game, it's a green ball of gas, or possibly interstellar snot, I don't know. But in any case, here we are approaching the Julian atmosphere at about 10 kilometers per second. So we will see how that goes. Before we hit it, we're going to do our science near Joule. Let's see, one space near Joule, 70 science points only from the goo. This is underwhelming. I would have expected more points from going so far. But then again, we did only bring the goo. We didn't bring the materials bay or the other high science things. The pressure sensor is still in a vacuum, but that will soon change. Let me see if I can't rotate the spacecraft. I want to find my thermometer. Here it is. The thermometer doesn't want to display anything anymore. That's a bother. So I'm going to time warp a little bit until we are even closer to Joule. We're at 500. We're quickly dropping in altitude. So I reckon this already counts as in atmosphere, in space near Joule. Transmit that. Oh dear, we're getting the shock heating already. We are definitely in Joule's atmosphere now. I'm going to transmit the goo. It still says in space, but this heating effect implies something else entirely. We're decelerating at 0.1 G. And let's see if we can set... Why can't we do an atmospheric scan? We are definitely in a pressure zone. I'm a bit disappointed by the science on this mission, because my instruments apparently just refuse to function. Observing the goo again. Not in space near Joule. We are in Joule, for Christ's sake. Oh no, and our electric charge has run out. So we are in sunlight, we are recharging. Hopefully the solar panels are withstanding this heating. If not, that would be a problem. We're under 100 kilometers of altitude on Joule now. Let's see if we can observe the mystery goo. Still in space near Joule, going to trash it. And there, way in the distance, is the sun. Very, very small indeed, and only slightly charging the solar panels that we will need to transmit this data back. And as you can see here on the map view, we are not going to get a second pass. We will in fact plummet down into Joule forever. So not a great success on this probe. I'm back. I had a small mishap with the recording software. Fortunately the game didn't crash, so we can pick it up right where we left off. I'm not completely sure what I was talking about, but what is going on is that the probe is rapidly crashing into Joule's atmosphere. We're currently decelerating at a good 6 Gs and losing all the speed and falling down. With that fact, I was planning, this was one of the projected possibilities, and I was planning to transmit science back while passing through the different layers of Joule's atmosphere. A problem with this is that the battery is completely empty, and the solar panels are only recharging it very, very slowly. We have here a 120 point value goo measurement, but we don't have the power to transmit it. So I'm going to put all these data in the antenna to transmit and hope that the probe will not disintegrate before the panels have had at least a small chance to recharge and transmit some of this data back to Kerbal. I'm going to try and turn the probe around so that the solar panels might possibly get a little bit more light, a little bit more illumination, allowing more transmissions to happen. We are still rapidly slowing, but I'm hoping that the atmosphere is thick enough that we will in fact get a sizable amount of data back on Kerbal. Now we have managed to transmit a little bit. Unfortunately, that was one of the science experiments that had a fairly low science value. We're still at 60 kilometers up. The atmosphere shouldn't be too crushing as of yet. Flying at Joule, we can transmit this again. We are, when I manage to do turn around, this wiggling is helping. Perhaps when we get into the lower parts of the atmosphere and start to go a little bit slower, the engine and the fuel that we have might be able to sustain us at an altitude for a few minutes, so we can transmit some science, because there is no question about it, this probe is not returning from Joule. It's not going anywhere. It is definitely crashing. So log the temperature. We have a 96 science temperature scan at Joule. Transmit that, or at least put that in the transmission queue. And we are going to look at the pressure data as well. The pressure is immense. The instrument is beginning to fail. Quickly transmit that. We are getting some good science points here from the sensors finally. The problem is that we may not have enough time to actually transmit this information. Additionally, it seems as though the probe is going to be stuck in this dense atmosphere head down, which is not the ideal angle for exposing the solar panels to the sun's rays. So I'm wondering if we can see the data queue in the antenna. No, we can only... Ooh, we got a little bit of data from... We need 10 charge for each portion of data. So I'm going to just look at the energy screen here and try and find an orientation that gives us the most power per second. So the most I've seen is minus 56. Going to try and keep it there with the stability control. We are still plummeting, but we are still also going forward at about 1,000 meters per second. Let's see. We still have about a minute before we come to what this thing here describes as the surface. So we could possibly still transmit a little bit of data. We are transmitting 0.8 data per 10 charge units. This is probably not going that well. Oh, we are only going at 115 meters per second relative to the surface. We have some time still. Getting 8 science points in. We're just going to wait. Let's have a look at this mystery goo. Is this a different measurement yet? No, this is not a different measurement yet. Look at the... We are still decelerating at almost a G. This is crazy because our speed doesn't indicate that. Pressure data. I'm loving the pressure data here at Joule and the temperature data as well. 0.8 data. We need more. We need more electricity. I'm going to try and fire the engine to turn around. We need to get this right side up. We need to get this right side up. This engine firing is not doing anything for us. Maybe we can rotate it 60, 70. That is the best we have so far. 0.70 electricities. And we are now just slowly transmitting all this data while the probe is sinking in Joule's atmosphere. Well, there's little more you can do about that at this point, rather than sit back and enjoy the view. As I mentioned earlier in the video, the topics on the Kerbal Space Program forums are very worthwhile visiting. There's a lot of good YouTube channels there. Check out my friend Jay Cheetah's channel as well. It's in the featured channels on the top right and on the bottom of my channel. And of course, if you've been liking these videos, make sure to subscribe, to like, to leave a comment. I always like that. If you have a question, a comment, post it in the box and I will give you a personalized reply. In the meantime, we can have a sneak peek at the mission controller, because I'm having... Oh no, we're not going to have a look at the mission controller yet. First things first, we need to get the science out of the way so we can get the full sensor suite in order to unlock the next mission in the mission controller here. If we have a look at the missions we're allowed to do, the Sputnik 4 requires this GravMax negative gravioli detector. If we manage to get 200 science, 200 and something science it was. If we manage to get that from the mission, we will be able to fly it. Otherwise, we are going to have to attempt another science mission at the... I'm estimating I'm going to need 20 to 30,000 to put that science probe of the mission in orbit. We have about 30,000 for a breakneck, get that last science point mission. But the science here, while this probe is sinking towards certain doom and destruction, the science points are steadily flowing in. The solar panels miraculously are getting some sunlight from that very distant sun, and every 1.2 data we receive from the scans, from the readings, net us some good science points. So I'm going to keep on struggling here. There's not a lot else I can tell you about this. I'm just going to see how much charge I can get out of the solar panels, how much science we can transmit before this probe sinks to its death. I will fast forward that for you and stop talking. See you back at the Space Center. Right, so here we are at the Space Center. There, while the probe was getting near to the center of Joule, there was some black abyss. I'm going to interpret that as the failure of the sensors on the probe, and shortly thereafter it was crushed by the pressure. Now, the moment supreme, did we get enough science? Was this somewhat botched mission? But then again, it was the first time going to Joule, so not all orbital parameters are known to a T. Was it successful? Have a look here at the screen, and oh my god, was it ever successful. We managed to get about twice as much science as I was hoping for. We are now at 993 science points. So let us get immediately out of the way this gravioli detector, thus unlocking our first paid mission again. Now we have a choice what to do with the other techs. We have wheels here. I'm still not enthused about the wheels. We have rovers here that could be interesting for moving around on Val, our target for this series. We have large solar panels here. These are definitely interesting because we will be going far out to Joule, and these giant solar panels will allow us to get some electricity still. Ion thrusters, they can be nice for having a large amount of delta V, but everything will go very, very slowly. Unmanned tech, a better or different or somewhat the same unmanned core. I don't really understand the difference between these unmanned cores. Sure, the shape is different, but they all do sort of the same thing. What we have here, no idea. We will need this for that. Aerodynamics, fins, wings, jet engines. No, not interested in that. Here we have specialized construction, docking ports. Yes, we definitely want the docking port. I'm just going to go ahead and research that right now, because from now on we will quite often be using docking ports, either to have detachable landers that come back to a mothership or to assemble large ships in orbit. These things are all quite necessary to mount missions to far away places. Here we have the advanced metalworks, new designs that allow craft designs that were considered insane not too long ago and still are, but they're now possible. So another docking port, radial attachment point, a defective docking port, a quad coupler. Great, so this is just more toys to play with. Keep that in mind. Specialized control here. The lander can, this is a nice control pod for a lander. A SAS module, larger parachute, a larger capsule for bringing more crew, and a place anywhere linear RCS port. Very interesting. Here we have larger engines and larger tanks. We are definitely going to need this, so I'm going to get that. And this nuclear symbol looks very inviting. And the tree here suggests that we are going to need the specialized control for that, but Oopsie daisies, all the science points have thus far been spent. We can still get this, the aerodynamics bit, or we could get this, the wheels. I am going to go for the aerodynamics bit. No, I'm not going to go for the aerodynamics bit at all. I'm going to save the science points. I'm going to end this video. Tomorrow we will be doing a mission controller mission. It will be a fairly simple mission. The mission to put a sensor package in a high circular polar orbit around Kerbin to get some money back in the bank, because the bank is going dry. But we can celebrate, we did go to Joule. So, end of a rather long video. As always, if you liked it, leave a comment, subscribe, have a look at my featured channels, or share it with all your friends, whichever option you like. If you want to help me out, those are the ways to do it. Thanks for watching, enjoy your evening, morning, afternoon, or whenever the time is that you're seeing this, and goodbye.